Hello everybody, I'm going to show you a demo today of a new startup called GRIDisc. So what this is it's a cloud optimizer that makes this really easy to distribute your code and all of your data onto the cloud and run machine learning optimizer to solve it. So first we're going to name our project. Here we're calling it Hello World. And this is what we do in case we have multiple projects running at the same time. We want to be able to find them quickly. And next we're going to put in our Git repository link. And here you can see I've got a password. You can have password, passwordless Git links. And so this is going to tell this tool where all of our code and data might be that we want to run. And then next we're going to want a function. This is called your fitness function. Some people call it an objective function or a cost function. We might be downloading thousands of different functions. This tells us which one to call. And this global function flag, for this demo they're the same, but this is a special function you can call when you've hit a new minimum. Of course, with any optimization we need to put in our limits. Here I've got upper limit, lower limit to constrain the optimization problem, because you can see we have a lot of inputs. And then minimum step size 0 is there is no limit. And then we're going to tell it 15 nodes and click run. So it's going to connect, the Git repo is downloading in the background, and we're off to the races. So here we are. This is running on 15 nodes, and as you can see it's just screaming along. If you look, and since this is an interactive JavaScript plot, you can mouse over any point and see what the inputs were that caused that simulation to happen. So the y-axis, this is cumulative return over a 2-month time period, and you can see the skew on the population is going up. So we're definitely making progress. And if you look down at the console, you'll see the machine names on different nodes and the inputs and the outputs. The same information you're seeing on the plot, just in a different format. But since this since this is in the browser, we can just leave this simulation, we can close it, we can go listen to Pandora, do whatever we do on the web, go to someone else's computer, and as long as we have the link and we can authenticate back into the system, we can pick up right where we left off, which is pretty cool. Let this run overnight, pick up in the morning, and you can see the skew has already changed dramatically. We're above 63%. So what did we just do? So there's a barrier to entry with a lot of technologies, and this one is quite high. So we've got optimization coupled with scheduling, and we've got asynchronous and distributed queuing. So this is a brand new resource scheduler, totally optimized for optimization. Infrastructure as a service, Amazon Web Services, instance names, all that stuff, building up a network. Distributed storage. So there's distributed storage going on, and this is what we're calling cloud optimization. So we've taken all these technologies and we've wrapped them into GRIDisc, and the end user is oblivious to what is really going on. But I know the DevOps guys want to see, so they're saying, show me the back end. So I'm going to show you right now. So the left terminal, you'll see that this is our master. We're going to execute this. And on the right, we have 15 slaves. So here we go. We're executing it. This is downloading the Git repository, and you can see it live here in the terminal. And now it has the jobs ready, and the slaves are cranking away. And so this downloaded the Git repository, and it was able to distribute it onto all of these nodes in a very efficient manner. And now it is working together to solve this problem. So somebody with no background in optimization or distributed computing or distributed storage or Amazon cloud management is executing whatever code they want to execute on as many nodes as they want to execute it on. It's quite remarkable. And here you can see what the end user sees. So they just see all this data streaming, which is what the master node is reading off of the slaves, but on the back end it's really really awesome what's going on. And you can see it's converged. So in a short amount of time this difficult problem has converged since we've distributed onto 15 nodes.